Okay, we're going to take a look at the hypothesis. As you see, we have a term bank here in the hypothesis, so we'll use these to answer the questions. Question 1, what are words or variables that mean the same thing as slope? So m would be one of them. So I will cut and paste that. What else? Growth value is slope, because slope is, the change in y over the change in x. It's how something changes, so it's how it grows. It's rate. Rate is how something changes, so rate of change or just rate. So I'm going to go with that. It's not start value. It's not the y value when x is 0, but it's the change in y divided by the change in x. That is true too. So all of those things are sort of synonyms for slope. What are words and variables that mean the same thing as y-intercept? Well, of course, the variable is b. It's not the growth value. I think I already did that. I should have cut it instead of copying it. It is the start value, though. And then it's also the y value when x is 0. It's another way of always thinking about the y-intercept. Okay, predict. Will we always be able to graph a line if you're given a slope and a y-intercept? I don't see why not. It seems really likely that anytime you have a slope and a y-intercept, in y equals mx plus b form, yeah, it should be possible. Okay. Can you always find a solution to a pair of equations by graphing them? That's a tricky question. What that means is if you graph two equations and they both make lines, a solution would be where the lines cross. And I guess you'll always be able to find the solution as long as the lines cross. You'll be able to find a solution. So you could say, as long as the lines cross, there is a solution. And can you always find a solution to a pair of equations by using a table? Let's go up to the table that we saw before. We'll notice that the solution would be where you get exactly the same number. And right near 7 you see it, but you don't exactly get the exact solution. We see how Jason is a little bit behind Freddy after 6 seconds, but he's a little bit ahead of Freddy after 7 seconds. So we know what happened between 6 and 7, so it's not as precise. We can't tell exactly when the solution is. You can't tell exactly where the two cross. So can we always... we say it's not as precise as using a graph, but it can help you, I'll use the word approximate. That means to tell about a solution. So you might never be able to find a solution, but you can approximate a solution. And that works.